Hello everyone, welcome to the new chapter Orthographic Projections. In this, we'll start with the basic session 1. Okay, now it is basics of orthographic projections. These basics of orthographic projections I've already told you in the isometric projection. The same thing I'll make you recollect some of the facts what we have already done. See here, in any problem in orthographic projection, they'll give the isometric projection like this. Okay, isometric projection will already be there. They'll give this and they'll give the direction of front view. Front view can be here or front view can be here. Okay, if the direction is this way, if you look from here, how it appears in the front view, and if you look from the top, that is in this way perpendicular to HP, how it is seen in the HP, that is top view, has to be written. Okay, these are all the basic problems. We'll cover it as fast as possible. See here, this isometric object will be given and this is the orthographic projection you are supposed to do. Okay, basic problem 1. Okay, now you see here, this is what you are interested. Okay, now you see here, when you are looking from here, it is 50, 50, 50 height, 50 size means it's a cube. That is why immediately write this 50 here in the front and top also 50. That means top view 50 square, front view height 50 will immediately say it's a cube of size 50. That means one solid is already over. Okay. Okay. Now you are looking in this direction. Okay. Over that you have a sphere of radius 25. Radius 25 means it is a diameter of 50. Okay. That's why you take 25 here. From here you draw one circle of diameter 50 in the front view. In the top view also it is the same circle of diameter 50. This completes front view and top view, which we have already discussed. Please understand, when you are doing orthographic projections and all that, never bothered about isometric scale and all that. Actual things, okay? Even if it is ISO 50 or 50, whatever they give here, same thing you do it here. Don't take any scale in orthographic projections, okay? Whatever is that, you write it down. Okay, what you have already done in isometric projection is, they'll give this, you have to do this. There, the combined axis is isometric and all that. This will reduce it to 25 ISO and all that. Those things will come in the isometric projection. Now you are doing the orthographic projection, which is comparatively easier. You look in the direction of the front view. Be careful. When you look in the direction of front view, okay, the front view direction is always perpendicular to VP. Imagine VP parallel to this. Okay, imagine VP parallel to this behind that. When you are looking here, how it appears on the front view, how it appears in the top view when you look perpendicular to HP. That is, when you look perpendicular to HP, how it is seen in the top view. When you see the direction of vision is perpendicular to VP, how it is seen in the front view, those things have to be written. That is the front view and top view of this particular solid. This is the thing that they'll give. You are supposed to write this. This is a simple problem on orthographic projection. Okay. Now there is another problem, basic problem 2. Here you see here, they are given this. The basic solid is ISO 80 square prism, thickness 20, upon which you have a square pyramid. Frustum of square pyramid, frustum of a square pyramid, bottom square 40 and top square 20. Okay. Once it is bottom square 40 and top square 20, you have to draw the corresponding orthographic projection. That means the front view and top view of this. Okay. Now let us say I look in this direction, or I can look in this direction also. If I look in this direction, it is 80, 20 in the front view. Correct? No? It is 80, 20 in the front view. First you concentrate on the bottom solid only. 80, 20 you draw and immediately write the corresponding top view. When you look from the top also, it is 80 only. That is square prism is 80. Don't take any scale and all that. Actual dimensions. 80 means 80. 20 means 20. In that way do. Then as you know, this is 20 square iso, the 20 square, first term of square pyramid. Bottom square is 40, 40. Bottom square is 40. Top square is 20. Height is 60. Okay. Now what do? You are looking from here. This edge is this edge. Okay. And as you know, this edge, this is 40 square, no? 40 square. This is 20 square. When this is 40 square, when you're looking from here, this what you see is 40. You draw 40 and height is 60. You go to a height of 60 and this is 20. This is 20 you draw. Okay, this is 20. This is 40. You join the outer boundary. Okay, that means this trapezoidal thing, what you see in the front view. When you come to the top view, okay, see here, when you're looking from the top, base solid anyway square. The top solid, you are seeing two squares. One 20 square you see, another 40 square you see. Okay. And these are all the slant edges that you don't forget to write. Okay. Once you write the slant edges like this, 4 slant edges here, looking at the top view and front view only, you can imagine this isometric projection of this one. Okay. That is why you have to know both the concepts clearly. Now we are doing this only. For the examination, they will give the isometric projection. They will ask you to do orthographic projection, which will be done this way. Okay. Did you follow here? In the same way, you see here, problem 3. Draw the orthographic projection of the isometric object shown, looking in the direction of the arrow shown. F. Arrow shown for drawing the front view. Okay. Now you see here. See here, the bottom solid. This is the object given, isometric thing they'll give. They'll ask you to draw the corresponding orthographic projections, front view, top view. And they're given the direction of front view. You see here, they might give here or here, I told you. Anywhere they can give. Okay. You can, anyway they can give either here or here, you just see. Okay, nowadays, base solid is isometric 80 and thickness 20. Square prism over which you have a cone of diameter 50 and height 70. Okay. When you are looking from this direction, when you are looking in this direction, please follow. When you are looking in this direction, when you are looking in this direction, you see this is parallel to VP. Correct? No? Because we are doing my direction of vision is always perpendicular to VP. This is anyway parallel to VP. 80 by 20 actual. You draw 80 by 20 front view. Front view of the bottom solid. First you finish the bottom solid. Then immediately take the projectors down and the top view of the base solid is 80 square. Can you understand? 80 square, 80, 80 you draw. Then when you are looking from here, the cone will appear as a triangle in the front view. Okay. The diameter is 50. 50 is the diameter. From the center you take 50, 25, 25 in that way. This is 50. Height is 70. Draw the triangle in the front view. Once you draw the triangle in the front view, top object, front view is completed. Immediately come to the top, come to the project, draw the projectors down. At the center, you draw a circle of diameter 50. Diameter 50. That means front view, top view of both the objects have been drawn. Please understand, this is the orthographic projections. In the examinations, they'll give this. Looking at this, looking in the direction of front view, when you look in this direction, how it appears in the front view is this. When you look in the top direction, perpendicular to HP, how it is seen in the top view is this. In that way, front view, top views have been drawn. This is called orthographic projections, what I've shown you here. Okay, please understand, engineer's drawing is this. In engineering environment, in the shop floors and all that, you will have top view, front view given, not the isometric view. When you look at the orthographic views, you should be in a position to imagine how the object is, how the machine component should be. For machine component or whatever it is always the front view, top view, side view or front view, top view, only that is given. Looking at that, you should be in a position to imagine how the solid is, and you should ask your worker, see here, this is how the object is, and you can draw the isometric view and show it to him. This is how the object is, and you should get the object in this way. That is the idea. Okay. Now for this, you see here, again I'll tell you, it is first you draw, when you're looking from here, 80-20 you draw actual, okay? Don't take any scale in orthographic projection, okay? It is just actual things. 80-20 you draw, immediately draw the corresponding 80 square, okay? That is the bottom solid, front view over, top view over. And when you're looking from here, the top solid also, it's a cone of diameter 50 and height 70. It's a triangle in the front view. And when you come to the top, take the projectors down here and from the center as the radius, draw a circle of diameter 50. In that way, front view, top view of the second object and the top solid is also over. Looking at the front view, top view, you can imagine how the isometric projection of this is that. Okay, will look like this. That you should know. Okay. Now, you see here. Now let us say another object. Draw the orthographic projection. Orthographic projection for the isometric object shown, looking in the direction of the arrow shown for drawing the front view. Okay. Now you see here. This is a simple thing again. Now you see here. This is at least a little bit of thinking you have to do. See here. My direction of front view is this. It's a rectangular prism at the bottom. Okay, when you look from here, perpendicular to VP, on VP you see 100 by 20 square. Can you understand? If they give the direction of front view this way, if they give the direction of front view this way, you draw 60 by 20 in the front view. Can you understand? Okay, that you be careful. Okay, if it is this way, 100 by 20 in the front view. If the direction of this is this, it is 60 by 20 in the front view. Okay, let us now it is this way. 100 by 20 square you draw. Immediately draw the projectors down. Projectors down. This is anyway 100, and this length will be that is 60. This 100 by 60. If you look at the top view and looking at the height of 20, you immediately know it is a rectangular prism. 100 by 60. Height is 20. Okay. Then you are looking in this direction only. Okay, if you look in this direction only, you just see here. This distance is 40. This distance is 50. Okay, when this distance is 40, when you are looking here, this distance should be 40. This is 50, means it is a square prism of sides 40 and height 50. That is why you take 40 here and draw height 50, complete the front view, and come to the top with centrally you complete this 40 square. Now looking at the top view 40 square, looking at front view 50 height, they'll immediately know it is a square prism of sides 40 and height 50, and at the same time the bottom solid, looking at the top view 100 by 60 and height 20, you should know that it's a rectangular prism of base sides 100 by 60 and height 20. Is it okay? This is how the orthographic projections are drawn. The front view is this, top view is this, you just write, and never forget to write XY line, VP, HP. When you're looking in this direction, for this complete solid, front view looks like this, top view looks like this. Okay, and in this way XY line and all that thing, VP, HP and all that you write, and finally write front view, top view and all that, and these things anyway you can make it dark. This front view can be made dark, top view can be made dark. This is the only thing you're supposed to do in the examination when they ask you orthographic projections. Sometimes the side view will also be asked. I'll tell you later in the chapter how to draw the side view. Okay, now we'll come to the end of session 1 on basics of orthographic projection. Thank you very much for watching. We'll continue this in session 2.